Hello friends, in the current video tutorial I am going to talk about displaying multiple plots on a single waveform graph which have some specific start index and specific increments on the x-axis. So when you are going to display multiple plots on a single waveform graph with some specific start index and specific increments on the x-axis, then we have to draw a cluster which has an initial value x0, a delta x value which is the increment at the x-axis, and a 2D array of y data. 2D array of y data has multiple plots, and each row of the 2D array of y data is interpreted as an individual plot, and the increments are counted from x index, which is x0, the initial point, and the increments are actually delta x. They are counted from x0 and the increments are delta x. This type of data is useful for displaying multiple signals that are sampled at the same regular rate. So now let's see on the software how this multiple plot with some specific increment and specific initial value at the x-axis is plotted. So as you see on the block diagram, we have three different values, three different arrays of values which are to be plotted. The first one, values are generated from 0 to 10 values. The second, values are generated from 0 to 20 values again, and the third one is generated from 0 to 30 and again 10 values. These values are combined together in the form of a multi-dimensional array, means two-dimensional array over here, and using the build array function, and then the values are collected in a 2D array over here. And then we have the initial value, delta x value, and these are bundled together to form the output cluster, which is this, and the waveform graph is plotted. If we see the placement of the things, so this is the 2D array, and we have this cluster which is combined over here. This is the cluster to plot the final data, and this is the initial value, and this is the increment delta x. Now I'm going to run and plot the data. So see, three data are plotted. The first data at plot 0 means this whole first row of the 2D array is plotted as plot 0, starting value 3.276, which is plotted as plot 0 in the white. So this white colored plot is plot 0. Then plot 1 is plotted. Plot 1 is this second row. All of this second row is plotted as plot 1, and the starting value is 14.41, and it is plotted in the red. This is 14.41, so this is plotted in red. And the third plot, which is actually plot 2, and plot 2 is plotted as this row, complete row, the third row of this two-dimensional array. So all of this is plotted in plot 2. The starting value is 23.6263, which is plotted as green. If we see the cursor, we have different values. So this is the value number, index number 1, sorry, and then we have I have to use this only. So this is the values 0 for 3 plots, then value 1, value 2, value 3, value 4, value 5, value 6, 7, 8 and 9. So the values are plotted at indexes 0 to 9. Suppose I want to change the initial value, I want to change this to 5, and I want to change the increment to, let's say, 2. Let's say 2, and let me change the x index to, let's say, 30. Maybe 40 would be enough. So now if I plot it again, so see, the values have started plotting from the index 5. The next value is plotted at index 7. The next value plotted at index 9, then 11, then 13, then 15, then 17, then 19, then 21 and 23. So 10 values plotted starting from 15 to last index 23, starting from 5 to last index 23, right? Starting from 5 and last index 23, right? 10 values. So I have changed the initial value where plotting starts. So the plotting starts from 5, and the increment value also changed to 2. So this is very flexible plot, and you can plot different plots with the same initial value and same increments. So we have seen in the previous plot that we have plotted multiple plots on the same waveform graph, but they had the same number of data points to be plotted. Each plot is having the same number of data points to be plotted, although they have the same initial value and the same increment delta x. But if we are going to plot multiple plots which have different number of data points to be plotted, although they may have the same initial value and the same increments, means delta x is same, initial value x0 is same, but they have the different number of data points to be plotted, then we have to do a different scheme. We have to use a waveform graph which accepts a cluster of initial x0 value, a delta x value increment, and an array of clusters. So array of clusters is the thing which we have to use instead of an array, which is combined into a cluster. So this is different than the previous scheme of things. Then each cluster contains a 1D array that contains the y data. Each cluster represents a single plot. The 1D array in each cluster describes the points in the plot. The number of elements in each plot can be different, means the number of data points in each plot can be different. So this data type is different than the previous one, and this data type is useful for displaying multiple signals that are sampled at the same regular rate. Means sampling time is same, means increments are same on the x-axis, but they may contain different number of data points, right? So the initial x0 value is also the same for all the signals, and which can be specified in addition to the delta x value. So the initial point is same, delta x value is same, but the number of data points to be plotted for different plots are different. So let's now see in the software how this multiple plot with different data points is plotted. So as you can see, we have this for loop generating an array of 7 data points. Then we have this for loop generating an array of 15 data points, and this for loop generating an array of 10 data points. Now these are bundled and then they are forming over here an array of clusters. Now this array of clusters is further bundled together with initial value and delta value to forming a output cluster which is plotted onto the graph. Now let's see on the front panel how these values are plotted. This is the output cluster and initial value and delta x value. So I'm going to run the program now. So see, there are 3 plots generated. The first plot or the plot 0 is in white, having 7 data points. The values ranging from 0 to 150. The second plot is in red, or the plot 1, which is having 15 values, data points, and the values range from 0 to 150, 0 to 100. The third plot or the plot 2 is having the values 0 to 50 and is plotted in green. So if I mark it, this is the first plot which is in white, then this is the second plot which is in red, and this is the third plot which is in green. So this is plot 0 according to LabVIEW convention, this is plot 1 according to LabVIEW convention, and this is plot 2 according to LabVIEW convention. See that the initial value from where the plot starts plotting for all the plots is from x index 2, and the increments are same 0.5. If I want to change the increments, I can change the increments. If I want to change the increments by, let's say, 2, so all the values will be plotted at 2 increments. Like this. Let's see the program once again. So this is the program, how we have plotted multiple plots with same with different data points but same initial x value and same increments delta x. So that comes to the end of the video. I hope you have understood the concepts properly and you have liked this video. Thanks for watching this video and come again.